Hello, everybody. Welcome to night 2 of our summer research experience student presentations. My name is Jen. I am the Program and Outreach Manager for the Headwaters Science Institute. I have over 12 years experience working in science education, as well as a background in outreach and event management. My specialty in science is marine biology and environmental sciences, as well as science research. I am excited to have our mentors joining us this evening. So first we have Christina Labuglio. So hi, Christina. Thank you so much for joining us and the work you did with our students this summer.
Hi. Yeah, it's great to be here. I'm really excited for night 2 presentations. Night 1, they did fantastic. So I'm sure they are going to do just as great today. But yeah, I'm Christina. I currently work for Auburn University, where I do shellfish research, and I focus on oyster reef restoration and aquaculture for the commercial industry, as well as research. But I also specialize in apex predators. I've done a lot of work with sharks, working with OSearch, and I also have a specialty in physical oceanography and climate change, where my thesis took place in Antarctica, looking at glacial ice melt in Western Antarctica. So yeah, I'm excited to be here.
Oh, we're so excited to have you. We're going to hear from a couple of your kids tonight, and I know they did an awesome job, so I'm really excited.
Yeah.
All right, so up next we have Daniel Dudek. You might hear him referred to as DJ throughout the evening, so I'm going to let DJ introduce himself to you as well.
Yeah, well, hello everyone. My name's Dan Dudek, also known as DJ, as Jen mentioned. I've been working with Headwaters as a mentor and a data analyst for about a couple of years, since 2018. So I've helped plenty of students go through this whole process of science and take them on the journey through designing their own experiment and sharing the results with all of you. I also have done a lot of research myself, mainly in the field of phylogenetics and species delimitation, taxonomy, ecology, and sort of just everything under the sun in biology. So I'm excited to be here and help share all the great student research being done.
Awesome. So up first for this evening, we do have Ethan, which was one of DJ's students. So I'm going to go ahead and let DJ introduce Ethan and have him come in to join us.
Yeah, so today Ethan is going to be starting off the presentations. He was actually one of the Headwaters Science Institute scholarship awardees. So he got to have his entire project funded, and he did a fascinating study looking at water quality across certain different types of areas within New York. So it was really applicable to the community and his society and the people around him. So take it away, Ethan.
Thank you, Daniel. So hi guys, good evening. My name is Ethan, and my presentation is on the comparison of the water quality between Chinatown and Bayside being a more affluent and well-funded region of New York City. So to start off, I want to mention how safe drinking water is considered a human right, since we all need it for survival and for adequate health. The Safe Drinking Water Act of 1974 allowed the Environmental Protection Agency, or EPA for short, to pass primary and secondary regulations on our drinking water. Primary regulations are enforced, while secondary ones are only recommended. So this act also required water suppliers to provide annual reports on our drinking water, so consumers know exactly what we're drinking. So for my study, I'm going to be testing for the pH and total dissolved solids, or the TDS. So a pH of less than 7 is considered acidic, while a pH of greater than 7 is considered basic. And the EPA recommends a range between 6.5 and 8.5 for pH. Total dissolved solids, or TDS, is a measure of dissolved organic matter and inorganic salts in our water samples. And the EPA recommends a TDS of no more than 500 parts per million. So in Flint, Michigan is an underdeveloped area, and that resulted in the pipelines being aged, and that led to lead infiltrating water. And people in Flint, Michigan are mainly people of color, and it's a pretty economically depressed area, which resulted in them having to drink the tap water, as bottled water is more expensive and most people couldn't afford that bottled water. So the two regions of my study is Chinatown and Bayside, and they're 14 miles apart, meaning that the pipelines are most likely to be different from each other. So the picture on the top right is Bayside, and the picture on the bottom right is Chinatown. And the majority of Chinatown residents make less than $25,000 a year, while the majority of Bayside residents make $75,000 to $149,000 a year. And 75% of Chinatown residents are Asian. So that kind of matches Flint, Michigan's demographic profile, as Flint, Michigan was also an economically depressed area with high rates of racial minorities. So the importance of my study is to ensure that no environmental injustices are occurring in Chinatown, and that the water quality isn't being affected by economic and racial factors. So all of New York City's water come from the Croton and Catskill/Delaware watershed, but depending on the region, the pipelines will be different, resulting in different water in each region. So to deliver safe drinking water, it requires renewed pipes, and Bayside received $62.5 million in renewing their pipes. So my research question is, how is the accessibility of clean drinking water different in Chinatown compared to Bayside, a more affluent and well-funded region in New York City? So the independent variables are the region of the restaurant and the building age, while the dependent variables are the pH and the total dissolved solids, or the TDS. And I expected to see Chinatown's water quality to be worse than Bayside's due to Bayside's renewed and well-funded water pipes and potential demographic preferences. By worse, I just mean the TDS will be greater than Bayside's, and the pH will be exceeding the recommended range. So what I did was first use Google Maps to locate 15 restaurants, and then I collected water samples from these restaurants and tested for the pH and TDS using the meters you can see from the first picture in the bottom. So these two graphs show a comparison of the pH and TDS between the two regions. Both of these had no significant difference in Chinatown Bayside in the pH and TDS variables, as the p-values are greater than 0.05. And this graph shows a comparison of the building ages between the two regions. And we can see that Bayside's building age is typically 55 years it's 55 years younger than Chinatown's building age. And it is a significant difference with a p-value of less than 0.01. This shows the relationship between the year built and the pH. And we see an R value of negative 0.42, meaning that there's a negative correlation. So as the year built increases, the pH decreases. And the R square value is 0.163, meaning that 16.3% of the variation in pH is explained by the year built. And this is significant with a p-value of 0.03. There is no relationship between the year built and the TDS with a p-value of 0.56. So there is no significant difference in the pH or TDS between Chinatown and Bayside, meaning that the null hypothesis will fail to be rejected. And even though Bayside received $62.5 million to renew their pipes, the water quality is still the water quality could be worse prior to 2018, which is when the infrastructure project happened. So the pipelines only improved it to match the water quality of other regions in New York City, which is why we see that the water quality is similar in Chinatown and Bayside. But this can't be tested, as there's a lack of information regarding Bayside's water quality prior to 2018. So one of Bayside water samples actually has a pH value of 6.35, which is below the recommended range of 6.5 to 8.5. This results in the water having a bitter metallic taste, and in the long term, if this water is continuously drinking, it could result in diarrhea, shortness of breath, and organ damage. No samples from either region exceeded TDS value standard. So the pH of a water is inversely proportional to the temperature, meaning that as the temperature increases, the pH of the water decreases. So when I collected my water samples, I waited around 6 hours before I tested for the pH, meaning that it could have resulted in inaccurate data reporting, as the temperature could have risen and then later my pH decreases, or vice versa. So in the bottom right hand, there's a picture of the Wando Genetic Campus. It's in Ethiopia, and all sampling sites here met the World Health Organization standards. That shows how developing countries aren't always aligned with poor drinking water, which relates to my research, as Chinatown, an economically depressed area with high rates of racial minorities, also isn't aligned with poor drinking water as we may suspect it to be due to previous research such as the Flint, Michigan water crisis. So since my study showed a negative correlation between the building age and the pH, a future research question could be how the year a building is built influences the pH of its water. Also, in Bayside, pipelines above the houses above where the pipelines are upgraded could potentially be better or worse than pipelines below where houses aren't that, because could be better than the houses where pipelines aren't directly above where the pipelines are upgraded. So a future research question could be how the water quality of houses in Bayside that are directly above where pipelines are upgraded differ from houses elsewhere. So for my acknowledgement slide, I'd like to thank Daniel Dudek for mentoring me throughout this entire research process and meeting me weekly to help me with manuscript writing, presentation, practice, and just helping me in general. And I'd like to thank Jennifer for teaching us the process of manuscript writing through weekly meetings. And I'd like to thank my peers, Tiffany, Jonathan, and Ian for reviewing my manuscript and providing thoughtful feedback regarding it. And I also like to thank Headwaters Science Institute for awarding me the scholarship to attend this program and purchasing my materials. So thank you. And these are my references.
Right. Well done.
Thank you.
Yeah, great job, Ethan.
Just coming from Headwaters in general, I just want to tell you congratulations as a scholarship recipient. You continuously blew us away this term. DJ and I spoke very highly about you every time your name came up. So congratulations on that job. Well done too. And I also wanted to applaud you on doing a project on something that's so close to home for you, like something that's important in your local community, because finding a project that you're passionate about and care about and can relate to your life is just such an important thing. So well done on all those fronts.
Thank you.
So DJ, Christina, do you guys have any questions for Ethan?
I think I have one. So I'm actually from Long Island myself. So small world there. Have you looked into or thought about how the pipelines may differ also between, because Bayside is very close to other parts of Queens, like Flushing and stuff. So have you looked into what those pipelines may look like for their drinking water? Because I know Flushing has been on the way up recently. I don't know what that water looks like or anything, but any others within close proximity to both Bayside and Chinatown?
I haven't conducted a study in the testing of water quality in Flushing, but the pipelines also actually upgraded the pipelines in Flushing as well. Like the 62.5 million was split between those two regions.
Okay.
So yeah, it's probably similar then if it upgraded both pipelines. But
yeah. Okay. Yeah. Cool. That's it. That was a good presentation. It was really cool to see that, especially because like I'm very familiar with those areas myself. So it was really cool to see all of that.
Yeah, that was actually one of the things that I loved about the project, is that he was able to sort of study or design a project around, his region and make it applicable to, all of the people around him. And the funny thing we were, discussing when he was designing his project was whether or not the people at the restaurants would allow him to collect their water samples. But apparently everyone was, very, very receptive to him studying the water supply there. So that was cool.
Did they ask you for the results at all? Does anybody want to see what you found out?
One girl actually did. She was really curious on my project, and I explained it to her. But most people were just yeah, take my water. And
it'll be interesting to see where you go from here. Do you plan to continue on with this type of a study as you go on through education?
Kind of, yeah. I want to study environmental policy or law, or just I want to focus on environmental justice and stuff because I have an interest for that. But it'll be interesting to do related projects about this.
Yeah, such an important field to go into right now too. It's definitely growing. So
Yes.
well, great job, Ethan. We're very proud of you.
Thank you.
Yes, congratulations. All right, so I'm gonna pull DJ out, and up next we do have one of Christina's students. So we're gonna let Christina introduce.
Yeah. So Dylan actually had a really interesting project. I was a little unfamiliar with it at first, so it was really cool to learn everything as Dylan was learning, looking at all the papers. But what's also really awesome is that she taught herself MATLAB. I didn't learn MATLAB until I was in my master's program. So here Dylan is as a rising senior in high school teaching herself MATLAB. So that's really awesome. And the project turned out great. So I'm really excited for everyone to see what Dylan did with invasive species and crickets. Dylan, take it away.
Thank you. Hi, I'm Dylan, and I research the effects of invasive primary producers on native primary consumers. In coastal climates such as California, scenes like these are increasingly more common due to this particular invasive species. Using the Shannon Biodiversity Index, where H represents that value, H indicates low. I'm so sorry. H indicates low a low H value would be 0, which indicates low biodiversity and low species richness, which have negative implications for the surrounding ecosystem. Invasive species are organisms that are translocated from their native environment into a new niche and negatively impact that environment. Most often, this occurs through predation and competition, which can lead to decreases in species richness and changes to the composition of the environment as a whole. In this study, the invasive plant species outcompetes neighboring native species for shared resources and takes over the native species' realized niche. I focused on Carbobrotus edulis, or ice plant, which is invasive in California, Baja California, Australia, New Zealand, and parts of Europe. It's a perennial succulent native to South Africa, which was introduced to California in the 20th century to reduce erosion along roadways. It is very versatile, which gives it a selective advantage over many native plant species. It's able to grow in soils with high salt concentration because it stores salt in epidermal bladder cells. It's also able to employ both C3 and crassulacean acid metabolism, CAM carbon fixation. Carbon fixation is the light-independent reactions that work in tandem with photosynthesis, the light-dependent reactions, so that plants can convert oxygen and light and use light energy to create carbohydrates for consumption by creating C6H12O6. C3 is the most common metabolic pathway in plants, but plants lose significant amounts of water through transpiration. CAM differs because the plants are able to shut their stomata during the day to reduce transpiration and only fix their carbon at night. This allows Carbobrotus edulis to survive with little water, which gives it another selective advantage over native species. This plant is also able to form dense root mats to choke out other plants. Echeta domesticus, or crickets, feed on low-growing vegetation threatened by Carbobrotus edulis, and wild populations exist in California, which is why they were selected as the primary consumer in this study. Jaumea carnosa is a native perennial plant, which is just like ice plant, and it also shares many similar characteristics. They are both able to grow in high saline soils and have a very similar realized niche. To complete my study, I created 6 microcosms, which are closed systems that replicate the natural environment. Each microcosm had 5 crickets, 3 had invasive ice plant, and 3 had native marsh Jaumea. I took soil samples and recorded the masses of the crickets at the beginning and end of the experiment. For soil samples, I collected nitrogen, phosphorus, potassium, and pH levels. I also created an index to assess the health of the soil given these results. I also recorded my observations. Okay. Sorry, this is the wrong form. But to do this, so if we look in our, I apologize, appears to be the wrong file. I will continue though. So Jaumea carnosa, as we can see in the top left graph, initially had a pH of 6, but it approached alkaline and ended with an average pH of 6.83, whereas the invasive Carpobotus edulis, which is represented by the red line, held an average acidic pH of 6.5. If we look on the graph on the bottom left, you can see the nutrient values for potassium. So all nutrient values were on a scale of 1 to 5. 1 indicates depleted, 5 is surplus, and 3 indicates adequate levels of soil nutrient. So the value needs to be 3 or higher for healthy soil. As we can see here that for potassium, the native plant maintained its level of adequate nutrition value for potassium, whereas the invasive, which is represented by the red line, maintained levels of inadequate potassium level, although they improved throughout the course of the experiment. On the top right, I have my P changes, which both plants began with inadequate levels of P, respective with the native plant having a P level of 2 and the invasive plant having a level of 1, respectively. However, at the end of the experiment, the levels of phosphorus for the native species rose to adequate levels, whereas as the invasive species stayed in the inadequate levels of nutrition. And for nitrogen, both native and invasive plant species did not achieve adequate levels on average, although the only individual microcosms that reached adequate levels of nitrogen were native plants. So I also created a total soil nutrition index, which is the sum of the phosphorus, nitrogen, and potassium levels. So any value, which is represented by the yellow line, so the yellow line represents the an adequate soil health level, and anything less than that is inadequate. And the scale was 3 to 15 because it's the sum of all the possible values for P, N, and K added together. So adequate soil health was only achieved in microcosms with native plants, and I correlated that with the change in cricket mass. The R value for this graph was 0.619, so there's a strong correlation between the positive change in cricket mass and adequate soil health. So as the change in cricket mass increases in the positive direction, the soil health is also shown to increase and approach adequacy. On the right, I have my the number of cricket deaths plotted against the change in cricket mass. This was not a super surprising trend. I found that as deaths go down, the change in cricket mass increases positively because dead crickets are not going to be gaining mass. They're only going to be losing it because they're not able to eat or drink or really do anything at all. So yeah. My key results were that the native pH remained, the native pH approached alkaline, which in California, soil tends to be very alkaline. Between 7 and 8.5 is the kind of like the precise range that plants usually like to live in. And so I saw with the native plants that they were approaching that alkaline level, whereas the invasive plant species remained very acidic, which is not what the natural ecosystem would usually be. For the native plant species, the potassium and phosphorus values were adequate, but the N values were not. They were approaching adequacy, but they were not actually adequate. And for the invasive, all of the nutrient values were either depleted or deficient, and none of them were adequate. So there was also a linear correlation between cricket mass and number of deaths. So as I mentioned just now, the pH of invasive species maintained acidity, which has been shown in other studies because Carpobotus edulis is known to change the chemical composition of soil, which is something that I saw in my study because the nutrients maintained inadequate levels and the pH remained acidic, where if it had been any other plant that was native that would have been alkaline. Additionally, every cricket in an invasive microcosm died, which indicates that they do not feed very much on ice plant, although it's possible the deaths were not entirely due to an aversion of ice plant. It's possible that the cricket deaths were also due to dehydration or temperature because the microcosms were such closed systems. It's possible that crickets overheated even though they live in a very hot climate ranging from 80 to 90 degrees Fahrenheit. Another issue could have been dehydration because the ice plant is using carbon fixation. It's not losing as much water due to transpiration. And in a closed system, any of the water that the plant transpires is going to be available for cricket consumption. And because the ice plant is not having as much water transpire, there's going to be less water available for the crickets, which may have played a role in their deaths. Another reason that this could have happened is because the adult life cycle of a cricket is 6 weeks. So it was expected for there to be a lot of death in my experiment, but it was a very interesting result that 100% of the crickets in an invasive plant environment died. Another source of error is that there were ants that were around my microcosm, but they did not appear to invade inside. And additionally, the soil test results were based on a color spectrum, not a numerical scale. I transposed the color spectrum values into a numerical scale and then transposed those again into my final soil nutrition index. Additionally, the scales I used to record mass were often inaccurate, and that may have had an effect on my results. So there are a lot of this experiment could be expanded in various ways, including size, length, and using different species. A really good evolution of this experiment would be to add secondary consumers to the project, such as Sceloporus occidentalis or the blue-bellied lizard, because that would be a secondary consumer to kind of further the extent of the effects of invasive species in these microcosms. I apologize, this is the wrong file of my slides, but my works cited is somewhere, and I maybe can find it. But I wanted to say thank you to everyone who has helped me with this project, and I'm very grateful to Headwaters and my advisor, Christina, for all they have done to give me this opportunity to study such an interesting topic, and I'm very grateful. Thank you.
Awesome. Let me pull everybody back in. Yes, well done. And I do want to point out that Dylan has already had one of her peers request to use her research and replicate it with their environmental science program at school. So I think that that is amazing because that's the whole goal, right, of science is
Nice.
other scientists replicate your work. So job well done. He read your manuscript with our peer edits and was so impressed and excited that he asked for her permission to replicate. So I think that that's pretty amazing. So congratulations.
Nice.
Yeah, nice work.
Yeah.
Right. You guys have any questions, comments?
Yeah. So I think it was unfortunate that you had like 100% death for the crickets in that microcosm. Was that something you were anticipating going into it, or like was there some research that may have pointed to there being some type of aversion to eating that plant, or like do you think it's mainly contributed to that, or?
I think I did anticipate a lot of death occurring just because I ran my experiment for 6 weeks and the life cycle of an adult cricket is 6 weeks. So it was anticipated that there would be death, but because there was no predation, I thought that less of them would have died. But I think a lot of the crickets did not appear to, it did not appear that the crickets consumed the ice plant. So I think there was definitely a large aversion to it, but I think there are a host of other factors that could have contributed to the high death rate, such as temperature, dehydration, and yeah.
Well, what's really unique is that, if that is something new you just found out about the natural history of that particular cricket, yeah, you might have found something new out. So that's pretty amazing.
Yeah, I don't have any questions. I have already showered you with questions, but I just want to say good job again. And it was a pleasure going on this journey of crickets and ice plants and ant dilemmas with you.
Yeah, and she did have to, sometimes ants invade, right? So she did this project. She had to run her test twice, and she's still
Yep.
all of this, including learning that brand new software. So congratulations. It's an impressive feat in the time that you had. So good job.
Yes.
Thank you.
Good job, Dylan.
All right. So next up, we have one of DJ's students. I'm trying to pull Christina. So we're going to introduce Zach.
All right. So up next is going to be Zach Bell. I had the pleasure of working with him throughout this entire summer. There's been ups and downs, kind of some crazy things with the project, but I hope all of you are excited about listening to a widely debated or hotly debated topic. So he definitely chose a fun topic to dive into. So Zach, you can take it away.
For sure. Thank you. And so my name is Zach. And so my project is about plant-based meat versus, well, I guess real meat. And I kind of wanted to find out which is more free. And so, like Daniel pointed out, this is a very fairly controversial issue. There's a lot of different opinions on it, from whether people should just stop eating meat altogether, or as you can see up here, one of the headlines is that Bill Gates even suggested that we shift 100% to synthetic meat. So when going into this experiment, I was really trying to focus on mostly nutritional facts and data that I could gather, as in like protein, carbs, fat, stuff like that. And so I developed a hypothesis that what I thought would happen would be that there would be tons of nutritional value differences between real and plant-based meat. And how I went about finding this was that I would choose multiple different products from many different sources and judge them based on the nutrition information that was present. So before I go into all the data suggested and everything, I want to bring up like why this is even a point of contention. And so a lot of people have started going into started eating plant-based meats, mainly due to a large and still growing vegetarian and vegan base. And this provides an alternative to meat. So if people are transitioning from having eaten meat all their life, and now they're eating, and now they don't want to eat meat anymore, they want to go vegetarian, vegan, whatnot, and this offers kind of a bridge in between. And then also I want to point out some other information that I did not do extensive research on, but is still important information to bring up and keep in the back of your mind if you're a consumer. So there have been some other studies that have suggested that real meat can lead to cancer or other medical problems. And then also in plant-based meat, they have identified certain chemicals like propylene glycol and erythrocyan, which are not exactly good for you. They have many harmful side effects. And also plant-based meat does not contain cholesterol whatsoever, which eating a certain amount of cholesterol is good for you. But since plant-based meat is not, meat and cholesterol only comes from living animals. It's only produced in living animals. Plant-based meat does not contain cholesterol whatsoever, so you're not getting that in your diet if you're eating plant-based meat and not real meat. So, like I said, how I gathered my data was using many different sources, either like Costco or just other, or like the Impossible Meat website, and pulling their given nutrition data. And then I kind of, I guess, best way I could put that is standardize that because serving sizes obviously are not kind of like a one kind of like a one size fits all thing. So I need to kind of figure out how I was going to standardize that. And so what I did is I took each of the nutrients and I divide them by calories to get kind of a nutrient per calorie scale, and then I could use that to compare information between meat and plant-based products. And so through my results, I've gathered a bit more insight on which is healthier, and I will go over the results now. So for fats and lipids, I found that through confidence intervals that there is evidence of a statistical difference between real meat and plant-based meat, as shown here. There's the box and whisker plot, which just kind of shows your median, your interquartile ranges, your true ranges, and then the dot and whisker right next to that. That just shows the confidence intervals and whether or not there will be statistical difference. And so for sodium or salt, it's the same thing. There's slight evidence of there being a statistical difference. And for carbs, there was a very strong indication that there is a statistical difference between real meat and plant-based meat. For protein, there actually was no evidence of statistical difference between the two, which is kind of surprising, because one of the main concerns that a lot of people have with plant-based versus real meat is whether or not you're getting the same protein that you would have been getting otherwise. So now that we have all that information and you can really think about it, if there's only evidence of really a slight difference between real meat versus plant-based meat, and you're deciding whether one or the other is a healthy option, well, I would say look back to first look at your diet. What do you actually want to get out of your diet? Do you want one higher in protein, because you wouldn't really have an issue there? There's not much of a difference, although of course there are different types of protein, and that is one of the things I would want to do more research on. This is how the plant-based meat versus real meat differ on that, so that's something to take into account. And then also, like I mentioned before, I dove into the results and everything. There is certain things to take into account, like, there have been studies that say that meat can lead to cancer, or so if you have like a family history of cancer, then that might be something to be wary of. Or plant-based meats have identified chemicals in them also that are harmful to your health. So do you want to take that risk as well? So there's just a few different things to take into account as well. So and then, like I just said, if I was doing future research, obviously I'd want to find out what kinds of protein you're getting from each, and do more research on which is better for different types of people. And then also I also would want to dive into more quantities of nutritional nutritional things such as iron or vitamin B, vitamin A, stuff like that. And yeah, that concludes my presentation, and yeah, I'll field questions.
All right. Good job.
Thank you.
Yeah. So I guess the first question I have for everyone is, were you shocked that there's no sort of nutritional differences per calorie between meat versus plant-based meats? Because I think it's a pretty hot topic where everyone's, sort of taking their sides on which type of option you want to consume.
Yeah, I mean, I was a little surprised by the results, especially like I mentioned during my presentation. Protein, that was like, I was thinking that for sure. I mean, meat, real meat would have, I guess, higher protein per calorie, but no, there wasn't any evidence of that, which that was just shocking. I mean, I guess sodium does not exactly shock me as much for there being evidence of difference because I feel like since a lot of products aren't like pure meat. It's like a product, like it could be something that's fried, it could be something else. That then obviously there might be some skewing there with sodium, so that didn't surprise me as much. But I think protein definitely that just blew me away to find that.
Mm-hmm.
Yeah, I guess it depends on the like the vegan option that you're looking at too, because a lot of them do have like lentils and different types of legumes in there, so they would be a lot higher. When looking at those vegan products, did you notice a lot, like, because soy is another hot topic when it comes to vegan items, just because of the way they have to grow it and the farmlands? So did you notice any information as far as how much of that might be influencing any of your results? Like the amount of soy that's within it?
Yeah, that's actually another thing I could do some more research on is what each of them has, how much each of them has an impact, like soy versus, or like you said, legumes, beans, stuff like that. And I don't have as much data on that, but that would be something really interesting to go into, because I am aware that soy does contain quite a bit of protein in it. So yeah, I guess that's the best way I can answer that.
So what are your thoughts on alternative versus?
You stole my question, Jen.
Well,
sorry.
I mean, like, as for my personal opinion, I'm kind of a meatitarian, so like I just anything meat thrown from me, like I'll eat. I've eaten just all different kinds of meat. I just enjoy trying different kinds of meat and everything. I'm not as big of a plant guy, it's I'll eat things like, I eat broccoli, Brussels sprouts, stuff like that, soy, but not as much my thing, I guess. This is how I characterize my opinion on it. So I'll stick with real meat.
There you go. Sorry, Christina, I stole your question. Do you have another one for us?
No, I don't. That was my one question.
Sorry. Yeah, I was curious because it is surprising, the differences. And the protein is the thing that I think a lot of people don't realize, that, a vegan diet is very high in protein. So awesome. Very enlightening. Good information. DJ is our data master, so he was a perfect match for you to do this. So
for sure. I think this perfectly coincided with starting school too, because since our school had a problem with AP Chem, they had like a waiting list. So I got thrown to AP Bio, and we just started talking about confidence intervals at the exact same time. So I was like, that's just perfect.
You're like, I'll teach this.
Yeah.
No, that's great. That's just another testament to the experience that you had this summer and getting ahead of the game in your education. So good job on you.
For sure.
All right. So up next, I'm going to pull in, sorry, there's a lot of people on the screen, so it takes me a second to transition over. Next up is actually one of my students. His name is Jonathan. I co-mentored him along with another mentor named Rachel, who could not be here this evening. Jonathan went through a very nice little journey with trying to find his research topic. And he is really a true example of finding something that you care about and that you love to bring about this really interesting research project. So I'm going to go ahead and let Jonathan tell you guys all about his, and it's a little different spin too, which I love. So any kind of thing that you're interested in, you could turn into a research project. So I love how he spun this. So Jonathan, go ahead and tell him all about your project.
Okay, thank you. My name is Jonathan, and this is Effect of Sound Symbolism on Movie Music. So chords are groups of 3 or more pitches playing at the same time. And when we listen to a chord, we might feel different emotions, depending on what chord it is. For example, when we hear a major chord, apparently the file's not working, but when we hear a major chord, we will feel different emotions compared to when we hear a minor chord. And this is due to the effect called sound symbolism, which tells us that from a state of tension, for example, an augmented or diminished chord, when pitch decreases, usually into a major chord, society feels as if that is a symbol of strength compared to when pitch increases into a minor chord. And society feels as if that is a symbol of weakness. So just some basic information. Triads are 3 notes playing at the same time. However, it can't just be 3 random notes. It has to be a first, a third, and a fifth. And there are 4 types of triads, all of which depending on the distance between those 3 notes. Major chords have been found to sound happy. Minor chords have been found to sound sad. And augmented and diminished chords have both been found to sound unpleasant or it causes tension. And so my research question is, how does sound symbolism affect movie music? And my independent variable is the type of scene, and my dependent variable is the occurrence of triads. So for my materials and methods, I used the book 100 of the Best Movie Songs Ever and the book Great Piano Solos. And the general structure of this study is to find the pieces and then identify the triads. So first, I would find the category I want to analyze. In this case, it would be romance and action. And I would find 10 pieces using those books per type of scene or category. Then I would go to the original scene containing the music and analyze what is going on there to make sure it matches with my category. Once I have my pieces, I would take a look at the piano parts, both the right and left hand at the same time, to identify all the triads in the piece. Something that really helped me were chord markings, which told me the chord the composer wanted the piano part to play or the accompaniment wanted to play. Earlier, I talked about making sure the piece matched with the category. So when we're looking at the romance category, it would be anything that has to do with love. For example, if there was a wedding scene when the music's playing, I would consider that as romance. For action, it would be anything action related or anything that contains specifically physical violence. And examples of that can be chase scenes or shootouts. However, there are still a lot of things to watch out for when we're analyzing music. The first one being the general rules for triads. Earlier, I stated that triads are a first, a third, and a fifth playing at the same time, starting at the same time. However, on the bottom right, you can see that isn't the case. There are 4 triplets that are also considered triads, even though they aren't played at the same time, starting at the same time. So another way to look at this is what notes are being played within one beat. Another thing to watch out for is the many types of chords that we are not looking at. For example, sus chords, 6th, 7th, and 9th are all examples of chords we aren't looking at as we are only analyzing triads. Next are repeated notes, which are notes repeated across octaves. For example, if we have a C major triad, C, E, G, C, we would just look at it as a regular C major triad and ignore the higher C. For non-chord tones and pedal tones, those are both things we will also ignore. On the middle right image, you can see there are a bunch of examples of non-chord tones, and if you see anything that matches those examples, we would ignore them. Same goes for the images on the bottom showing the pedal tones. They can either be sustained or repeated rhythms. Finally, our omitted notes, which are parts of a chord that are taken out by the composer on purpose. For example, on the and B of 1 in the image on the bottom right, you can see there is a C and an E being played. However, there is no G, but we would still consider it as a C major triad, as we know the composer took it out on purpose. Moving on to the results, here is a graph of the romance scene music. We can see that there is an overall significant difference between all the types of chords, as the p-value was less than 0.01. However, there was no difference between the usage of major and minor chords, and there was also no difference between the usage of augmented and diminished triads. For action music, we found something really similar, as the overall p-value was also less than 0.01. However, this time we also found no significant difference between the use of minor chords and augmented and diminished chords. We could also look at each triad individually and put the two categories side by side. For example, for major triads, we found that there was no significant difference between its usage, as the p-value was 0.55. And same for minor triads, as the p-value was 0.65. And for augmented triads, we did find a significant difference, as the p-value was 0.03. And same for diminished triads, as the p-value was 0.04. So overall, we found that the highest occurring type of triad is the major triad, followed by the minor triad and the augmented and diminished triad. And when we look at the individual triads themselves, we found that there was a higher usage of augmented and diminished triads within the action music. And so because action scenes always contain conflict, and conflict leads to tension, and earlier we also established that augmented and diminished triads can cause tension, as they are more unpleasant to listen to compared to all the other different types of triads. It would make sense that action scenes contains a higher usage of these tension chords compared to romance music. And so although sound symbolism mainly talks about the usage of major and minor triads and how those lead to different emotions, we didn't find that there was a significant difference between those two types of chords within these two categories, and instead we only found a difference between the usage of augmented and diminished triads. However, it is also important to look at the potential sources of error. For example, instead of looking at 10, if we were to look at 20, 30, or 40 pieces per category instead of 10, we might have gotten a p-value that was significant, as the p-value was 0.07, which was really, really close. The second mistake might have been miscounting within the data, or when I was looking through the sheet music, due to the high amount of exceptions when I'm looking at triads. And those two factors might have contributed to the difference we saw in the augmented and diminished triads in action music, as the sample size might have been too small, or even though we did find a significant difference, the usage of augmented and diminished triads were significantly less compared to the usage of major and minor triads within these two categories. For future research, we could look at other genres. For example, instead of looking at romance and action scenes, we could look at happy or sad scenes, like at a birthday party or at a funeral. Next is classical and movie music, as one would expect those two to be very different. The third aspect would be time period and when the music was made. For this study, we mainly look at music from the 20th century, and future research could explore music from the 21st century. And finally, instead of looking at triads, we could look at other types of chords like sevenths, ninths, sixths, sus chords, and so many others. And throughout this project, I received tons of help. So I want to give a really, really big thank you to Ms. Cotton for general project management, and like she stated earlier, helping me with finally settling with a topic that I wanted to work on, and Rachel, who helped me with the music theory part and always answering my questions about music theory. This is my works cited, and thank you.
Yay! Good job. Very proud. Very proud of your work. All right. So does anybody have questions for Jonathan?
That was a really cool project. Like Jen said earlier, it's anything can be turned into a science project. So it was really cool to see that in this. And it's obvious that it's something that you're passionate about and something that you love, which makes it that much more beneficial to yourself and just as a research project in general. Do you play any instruments yourself? Like you know a lot about triads and sheet music and such.
Right. So I do play the flute, but I started, my very first instrument was actually the piano, which was the main reason why I knew how to read music. But I did stop playing and I switched to flute, and I've been playing for 5 years now.
Nice. Cool.
Yeah, and then I just want to say, I love the fact that your project sort of blended both art and science, and that's typically not something that's done often. The more science can move into art and vice versa, I think is a really fascinating sort of trend that's happening today. But I guess a question about your future research. So you mentioned how you wanted to look at different time periods. Do you think, one, I guess, what would be your favorite time period of music? And then two, do you think, the augmented sounds in the other category you had, do you think those would differ between the different time periods as well?
So for the first question, since I am born in 2007, I would enjoy the music from the 21st century more, especially Marvel music, as it always sounds really epic and really full. About the augmented and diminished triads, I honestly cannot say, but it is important to point out that the action music were also, a lot of them were theme songs, and when I was analyzing the original scene to make sure it matches with the category, a lot of them sounded a bit more happy compared to the songs from or pieces from the 21st century, which is a bit more serious. So I would say that there is a higher usage of augmented and diminished chords for the 21st century music.
Okay. Yeah, great answer.
Yeah.
And great job.
Yeah, I'd love to see if you look at any of those other time periods and even reflect on what the world was like at that time too. Like if you're going to look at music from like the 1920s, are you going to see a different type of tone than something maybe from a more, happy, robust time in the United States? Like it would just be really interesting to see all of that.
Mm-hmm.
Right.
Great job, Jonathan. Super proud of you. All right. So up next, we have Jordan.
All right.
Jordan, I just need you to turn on your camera, and then I'm going to go ahead and have DJ introduce you.
All right, everyone. So up next is Jordan. He's definitely going to be one of our youngest individuals who participate in the program. But I'm really excited for everyone to see what he's done. I mean, it's pretty impressive what he's been able to accomplish throughout the program. So Jordan, take it away.
So my project was determining ecological differences between the Hydrochaeris and the Hydrochaeris isothermus, also known as the greater and the lesser capybara. Capybaras are semi-aquatic rodents living in Central and South America. They usually live in marshy and swampy shallow water rainforest areas, and they live in medium to large sized groups and are very defensive of their territory. The greater capybara is of least concern on the IUCN Red List, but the lesser capybara is data deficient, indicating they currently do not face, indicating that there's not enough data on them to know, but the greater capybara the least concern indicates that they currently do not face threats from climate change or other sources. The population trend of the capybara is stable. And since there is not much data on the lesser capybara in studies, this led me to take an interest in the differences between the two species. However, studies do indicate that there are no differences in the habitat preferences between them, as I found when researching. My research question was, what are the ecological differences between the Hydrochaeris, the greater capybara, and the Hydrochaeris isothermus, the lesser capybara? My independent variable was capybara species and location, and my dependent variable was the bioclimatic variables as shown to the left or to the right. And the three bioclimatic variables that I used in my whole project was Bio2, which is the mean diurnal range, Bio4, the temperature seasonality, and Bio 6, minimum temperature of coldest month, as you will see later. And my hypothesis was that there will not be any differences between the preferences of the two species. Materials and methods. My first step was to use Wallace in R Studio to obtain location data for both species. My next step was to obtain bioclimatic data to create ecological niche models, or ENMs for short. And my third step was to analyze the bioclimatic variables that were used to create the models between both species at observed locations, and then create graphs for that data. Here is my ecological niche model, or ENM, for the Hydrocurus isithymus, or the lesser capybara. And as you can see here, this capybara resides in the more southern part of Central America and the beginning parts of South America, but that was not found the same for the greater capybara. And this is a heat map with different locations of capybaras, and this was as accurate as possible. As in Wallace, I made a set a distance, which was 50 meters, that so that any capybaras within 50 meters would be removed, so that they would not be the same capybaras showing up and make my data inaccurate. And the bioclimatic variable used to generate this model was bioclim2, which was mean diurnal range. Here is my ecological niche model, or ENM, for the Hydrocurus, or the greater capybara. And the bioclim variables used to generate this model are bioclim4, which is temperature seasonality, and bioclim 6, minimum temperature of coldest month. And as can be seen on the heat map, these capybaras live in a more northern part of Central America, which I found was quite interesting, that they didn't live in the same place, even though they're quite similar species, but not the same. So this is the first graph of 3 that I created, and the mean for the Hydrocurus, or the greater capybara, was higher than the mean of the Hydrocurus isithymus, or the lesser capybara. And the p-value that I completed after doing t-tests was 0.08, which indicates that there's no difference between the species, and the mean diurnal range was the same. And this is my second graph that I created. It's the results that I obtained for minimum temperature of coldest month, and the mean for the Hydrocurus, the greater capybara, was lower than the mean of the Hydrocurus isithymus, or the lesser capybara. My p-value that I determined through t-testing for this was less than 0.01, and that indicates that there is a significant difference between the two species. So already proving that my hypothesis was incorrect. And here the error bars, as shown, the blue bars to the left of the dots, and the dots are the mean of the animals. And this is my third graph for temperature seasonality, and the mean for the Hydrocurus, greater capybara, was higher than the mean of the Hydrocurus isithymus, lesser capybara. The p-value that I determined was less than 0.01, indicating that there is a significant difference between the two species. And here again, there are the error bars, and the dots representing the mean. The bioclimatic variables that predict suitability for the greater and lesser capybara are different. For all variables used to generate ENMs, there is a significant difference in temperature seasonality and minimum temperature of coldest month, but not for mean diurnal range. My null hypothesis was rejected, as I said before, because I found that there were significant differences between the two species in temperature seasonality and minimum temperature of coldest month. And this is significant because it conflicts with my background research, which supported that there was no difference. Future research. If I were to continue this study, I would use Wallace to collect the bioclimatic variables of other similar large rodents in South America to see if there is any difference. And actually continuing that, I would probably also use Wallace on other large rodents in other parts of the world, not just South America. I think South America would be an extended set portion of what I studied, but I think it would be extending even more by just testing other large rodents around the world and in the family of the capybara. And here my work cited.
All right. Nice work, Jordan.
Yeah, great job. Great job.
Good
First of
job.
all, I say I just love so much that you study the capybara because I love seeing them every time I go to a place that has them. So I was really excited to hear what your results were, just because they're just giant guinea pigs and they're so adorable. So I was excited to hear all about your little capybaras.
Yeah, they're adorable. They're like my favorite animal. And like about like 4 months prior to the summer, like doing my project, I went to the zoo that was near me, and they actually had capybaras. And that's kind of when actually seeing them in person and how cute they are. They became my favorite animal.
That's awesome. So again, taking something that you love and care about and turning it into a really cool research project. So Christina, do you have any questions? I know, or DJ?
Yeah. One, I just want to say it's pretty impressive at such a young age, using R and figuring out those packages and everything. So good job on that.
Yeah, Daniel helped
So-
a lot. I couldn't have done that, that's for sure.
But I have one question. So you said in your discussion that your results differed from a lot of the papers that you were reading. What do you think about that? Why do you think your results differed? Do you think it had something to do with the package that you used, or just what are your thoughts on that?
Well, I think one of the reasons why the results differed is possibly that in the research that I was reading, they were from lesser capybaras and greater capybaras found in more similar areas. But in my study, the package that I had was the greater capybaras that were more in Central America, and the lesser capybaras, which were more in South Central America and upper northern South America. So I think that could have contributed to it.
Mm-hmm. Yeah. No, it's interesting. I mean, that's what science is there for too.
It was really interesting to find, because I was fully expecting, even as I saw my hypothesis, that there wasn't going to be any differences. And even originally, I was reading actually that they were a subspecies, but as I talked to Daniel about, that's kind of just an ongoing debate in itself, whether subspecies are really a thing.
Yeah.
But considering they're their own different species, there's definitely differences to it.
Yeah, and I mean that's also what science is about too. You know, you're not doing the science because you already know the answer.
You're doing it because you want to find it out.
Yeah, you want to find it out. You want to continue the research and everything. So even though your results weren't the same, it's still a contribution in some way to that field of study, which is really cool.
Yeah, I'm really glad I studied capybaras.
Yeah.
Feeds future, research interests in you as well, to keep on going and studying it. Your results came out this way this time. What might happen with your future studies? So keep going with it.
Mm-hmm.
Yeah.
Keep learning about those little capybaras.
Yeah. And Jordan, I would just like to say, you did a fantastic job, and this is one thing that I definitely want to emphasize. In the very beginning, he was very hesitant on continuing this project because everything he was reading was telling him one thing. But now that there's this program called Wallace that was recently sort of went mainstream in 2018, it really allows you to look in depth about the bioclimatic niches of these organisms, and just really allowed him to easily generate those heat maps and also collect all of the environmental data or the bioclimatic data associated with those locations. So it's really fascinating that he was able to find some different results that didn't necessarily go and well, I guess it was kind of unknown because everything was data deficient, as we found with the lesser capybara on IUCN. So it just shows that you can find results. You can go against the consensus in a way.
Yeah, and it was just great to learn more about the lesser capybara, because there's not that much data on them. So kind of broaden out the amount of information on the lesser capybara.
I also love that you were able to study something that you love that's completely different part of the world than where you live too. So, I mean, I think that's just pretty incredible that you had access to that information to study an animal that's in a completely different continent, so.
Yeah, I mean, Wallace is amazing. You can study stuff that's on the other side of the world just from your own house.
Yeah, pretty sweet. Well, hopefully we'll see you with your own capybara, show at some point.
The capybara tamer.
There you go. Good job, Jordan.
Thank you so much.
I cut you off. You said have a good night. Sorry about that. All right. Next we have Lily, which is one of Christina's students. So I'm going to go ahead and introduce Miss Lily.
Yeah. So next is Lily. Lily started this program with me, super shy, I think, our first meeting, and it was amazing to watch her throughout this program just open up more and become so interested and so passionate about this topic, especially because it's right around the corner from her house. And it was just amazing to watch her blossom into this super excited scientist. So here's Lily talking about the Potomac River and eutrophication.
Thank you so much, Christina. And like Christina said, my topic is I will be presenting on a topic about eutrophication. Okay. The Chesapeake Bay and the Potomac River, along with other water bodies around the world, have been experiencing worsening water quality effect due to nutrients-related problems worldwide for decades. The important and fundamental problem in many coastal areas is the effect of eutrophication, the difficulty of amending the transformations of inorganic matters and the biological chains that yield cyclic contradictions from primary producers' catastrophes. And, as shown in the picture, the Potomac River is located in the mid-Atlantic region of the United States, which spans from Maryland, Pennsylvania, Virginia, and West Virginia, as well as DC. It encompasses all the terrestrial highlands area, which water flows from the mouth of the Potomac River and spills into the Chesapeake Bay. The substantial coastal shellfish, and fishery resources of the Potomac River region provide food for a significant portion of the world population. However, the resources have been greatly reduced by excessive nutrients that have altered the flow of energy through aquatic food webs. Human influence nutrients overload, including discharge from sewage treatment, atmospheric deposition to land and aquatic surface, and runoff from urban and agricultural lands. The excess nitrogen of is one of the major components of the degradation of terrestrial and aquatic ecosystem, because it's particularly difficult to remediate because of the multitude of province, which has like point and non-point sources, and the complexity of nitrogen transformation and the process of nitrogen and phosphorus input through denitrification, which is when nitrate and nitrite is reduced and transformed to principally nitrous oxide, which is N2O, and nitrogen N2 under anaerobic condition. And the root of the study stretches back to 1960s, when Vollenwender conducted an analysis on eutrophication problem. And this study was the first study to link the changes of the watersheds to the eutrophication problems. And Vollenwender conducted that controlling phosphorus input and nitrogen input to lakes was the main key in reducing eutrophication. And to be more specific, throughout the anthropogenic nutrient input, low ratio of nitrogen to phosphorus favored cyanobacteria to become diatom successor after silica concentration were depleted. And nitrogen was also rapidly depleted with increased phosphorus, which exacerbating the problem of nitrogen-fixing cyanobacteria blooms. With the predictabilities of this study, the geographical locations and anthropogenic influences of the Potomac River region may indicate the rate of nitrogen-based compound that represented eutrophication levels of the area and of the water. This study will be focusing on the nitrogen and phosphorus to the concentration to determine eutrophication in the Potomac River. We expect to see the changes in the quantity of compound due to geographic and anthropogenic factors. My material and methods. Throughout the study, I used API freshwater master test kit to test pH, including high range of pH and ammonia, NH3 and NH4+, and nitrite and NO3, NO2 and nitrate and NO3 of water samples that were collected in Potomac River. In every test, I used 5 milliliter of water for each test. That was like pH and ammonia and nitrate. And I also used like a clean tube and repeated the steps after. And this method were used for in a duration of 3 weeks. And those were the pictures. And I can give an example of one test. So for example, the ammonia test, I used 8 drops of ammonia test solution number 1 and 8 drops of test solution number 2 added to the test tube with the 5 milliliter water samples and vigorously shaked for 5 seconds. And then I waited for 5 minutes with the cap closed for the result of the total amount of ammonia in the 5 milliliter water sample. And my ammonia test results was obtained by comparing the color of the solution with the ammonia color chart in the test kit. And it was observed in a well-lit area. So to research precisely whether the Potomac River has a eutrophication problem similar to the Chesapeake Bay eutrophication problem, since these two extended ecosystems are linked as they intersect at Point Outlook, Maryland. And 3 sites on the Potomac River were selected to conduct the water quality test using the API test kit. And the first site is Blockhouse Point Conservation Park. And the second one is Georgetown Waterfront Park. And the third park is Chesapeake and Ohio Canal National Historic Park. And I chose ANOVA test for my data analysis test because of the type of number and of variable that I placed on my X, Y, and Z axis that dictated the appropriate statistical test for my analysis. And like shown in the picture, my graph had a numeric variable that was grouped by a categorical variable that was with more than 2 values. And this is my first result, and that I compiled from the BP park, which is a BPCP park. BPCP, which stands for Blockhouse Point Conservation Park, and then GWP stands for Georgetown Waterfront Park, and then COC and COCHP, which stands for Chesapeake, Ohio Canal Historical Park. And the first graph the first figure is a scatter plot comparing pH values with the 3 locations, and overlapping points indicate the same detected concentrations. And my p-value for this one is 0.3, which indicated a not so significant difference. And in my statistical analysis, the BPCP park had a mean value of mean pH of 7.86, and both the other parks had a pH mean value around 8.2. And I predicted that this was because of the high flow of stream, and the nitrogen cycle will be more difficult to overturn, and the pH value would be more difficult to neutralize and equalize before the water extends to the urbanized area in Washington, D.C. Therefore, due to the impact of geographical location on the when I collected the pH values from the 3 sites, that shows the difference between those 2 values. And the BPCP and GWP had a higher standard deviation value rate, more than a higher standard deviation rate than COCHP, because those 3 sites differ in was located in a different location, or different geographical location, because of the constant that resulted in a constant water movement at the CHP, because it was at a smaller canal that was diverged from the Potomac River, as opposed to the other 2 located in the upper and lower reach of the main stream. In figure 1.2 is a scatter plot showing comparison of NH3 levels by all 3 locations, resulted in a p-value of 0.85. And when the NH3 value from the 3 sample sites were put in comparison on the scatter plot, see in figure 1.2, the mean value of GWP and COCHP were higher than the BPCP mean value, because it was also in a different geographical location, which I will explain more in my discussion. And the next slide is another figure comparing NO2 values with all 3 locations, and the p-values were 0 because all of my concentration of NO2 were 0 throughout this study. And looking at the mean and the standard deviation value of GW park and COCH park, 2 values are the same, along with a 0.88 p-value indicating a insignificant trend. Comparing 0.88 to 0.87, which is a little bit less, but it's still an insignificant trend. And comparing NO2 and location in figure 1.3, and the data indicated both mean and standard deviation value were 0 because all the measurements were 0. And same to figure 2.3. And this is another scatter plot that I will further explain in my discussion. And this is a line graph comparing pH value by date. So my duration of my study goes from June 13th to June 30th. So there were some difference in between these days, but the p-value was 0.58, so there was still not a really significant difference. And those were other graphs that I made. That's NH3 levels by date, starting from June 13th to June 30th again, and overlapping points is the ones that have the same concentration, and this one, the p-value was actually 0.04, which is less than 0.05, which is more significant than the other plots. And this one resulted in the same, similar to figure 1.3, because all of my NO2 levels were 0. And starting with my discussion, as expected from my observed water quality as I visited all 3 sites, the presence of eutrophication in the Potomac River was indicated through trends in nitrogen cycling in the Potomac River. And looking from the lens of a geographical point of view, the Blockhouse Point Conservation Park is located more northwest of the Great Fall in Potomac. Therefore, the water travels in a faster rate, that's like 10,000 cubic feet per second downstream to the other 2 locations. And I believe that the high lake release rate contribute to the overall impact of the water current and structure and the water quality parameters. And so, although there's a small difference, but all of my p-values indications explain that there were no significant difference because my p-values were greater than 0.05. Therefore, the geographical location did not actually affect my pH values and my ammonia values and my nitrate and nitrite values. And as I researched before, a study conducted in China, they concluded that the total concentration, the average concentration of the 4 parameters will increase due to the water pressure when it increases. But that's why I hypothesized that it'll be the same for the Potomac River as it travels through the Great Fall. But however, my data value showed that the concentrations did not increase, but it decreased as it travels to DC. And another component is the weather, and which is the rainfall that had an impact on the runoff, which increased nitrogen compound, and the upstream rainfall is more frequent than the downstream rainfall combined, which increased the nutrients due to runoff. And it increased the ammonia concentration from the other 2 locations that were near DC. And one potential source of error in the study is the time frame of my sample collection, because the full nitrogen cycle takes about 2 weeks to 2 months. And I collect my data in a duration of 3-week period. So therefore, the nitrogen-based compound within the nitrogen cycle that I examined may not have turned over yet. And another biologically relevant source of error is controlling the performance when I used the test kit to test all of the values. There might be some human errors and the bias in interpretation. And in conclusion, although in general there were no significant discrepancy in locations and water quality for my data results, there were significant variation over time for different water quality parameters. In my future researches, I think that because since I kind of read over the Chesapeake Bay Foundation, their model project that predicted Maryland's if it's substantially on track to meet its 2025 pollution reduction target. And it turns out 2 of them were slightly and completely off track, and 1 of them actually meets the 2025 blueprint goals. So in my future study, I am interested to continue this work through 2025 and to see if other improvements have made, and then to actually observe throughout the entire duration of the nitrogen cycle, instead of just only doing a 3-week period, which could not kind of see the whole overview of the nitrogen cycle. And that would be something pretty cool to do for a longer time. And to my acknowledgement, thank you, Headwater Institution, for providing me this wonderful opportunity. And thank you, Christina and Jen, for supporting me through my manuscript and presentation. And thank you, DJ, for helping me with my statistical analysis. And thank you, Ashley, my environmental teacher, for introducing me to this interesting topic, eutrophication. And thank you, my mom, for driving me to all of my template sites. Thank you.
All right, good job. Yeah, you had quite a bit of sampling sites, so that was a nice little shout out from there, taking you all around.
Yeah, it took me like more, because I was actually timing myself, and it took me about like 18 minutes to go through my entire presentation with all of those like graphs and data. So I'm sorry about that for the extra like 8 minutes.
No, you did a great job. DJ, Christina, you guys have any questions, comments?
Yeah, I just have a question on your experience. So, I mean, you've clearly done a lot of, field work collecting everything. What like was that the first time you've ever done any type of field work, and what did you feel about it? Like, how'd you feel?
Yeah, it felt really good to actually like go outside during like COVID time, I guess, kind of COVID time. And I got COVID, and like, well, I was I think last week, so I wasn't able to kind of like continue with the field work, because I wished to continue like at least to like 4 weeks, like a month, but like I had to stop at the 3-week duration, which sucked. So yeah, that was my regret, but everything else went really well, and it's my first time, so I'm really excited for another field work.
Oh, that's great to hear. Yeah. See, I guess we got students, excited about doing field work now, so that's fantastic.
The fun part.
Yeah. Well, I just have to say it was amazing working with you, one, but also those last few weeks where you were sick and you did have COVID, and you still showed up to all of our meetings, and you worked really hard on your presentation and still working on your manuscript. So great perseverance through that. And I just love the tidbit at the end where it's, Maryland's goal through 2025 to continue to move towards better water quality and, move away from eutrophication and adding that extra nitrogen and stuff to the water. So I'd be really excited, and I hope you continue to do the testing until 2025 to see where Maryland goes, and if Maryland ends up, at their goal or exceeds their goal. So yeah.
Thank you, Christina. I will try.
Gotta have young people like you getting out there and getting all the information. So nice work, Lily.
Thank you.
Yes, good job.
All right, so that concludes our evening for night 2. If you are interested in participating in a program like this, we are currently enrolling for our fall semester, which starts on September 13th. You can find information on our website and all over our social medias. If you would like to directly contact me to get more information, you can email me at jen@headwaterscienceinstitute.org. Just want to say thank you again to our mentors, because you guys are the heart and soul of this program. You get the kids through everything with your expertise, and it's just such a privilege to have you guys joining us. So thank you. And hopefully we get to see you guys in the fall. We get to work with us again. So have a good night, everybody.
Take care.